Welcome everyone. In this video lecture, we will solve a numerical which is based on the negative feedback amplifier. So here we have considered an non-inverting operational amplifier, and this problem is from Sedda and Smith exercise 7.1. Okay, so we will solve this question. So the question is the non-inverting op-amp configuration shown below provides a direct implementation of a feedback loop, which is our negative feedback. So we have to find the following. Find an expression for feedback factor beta. Okay. If the open loop gain is 10 to the power 4, that is the value of A, then we have to find the value of R2 by R1. What is the amount of feedback? And Vs is 1 volt. We have to find V0, Va, and Vi. Also, we have to find if A decreases by 20%, what is the change in the corresponding AF. So in this case, our op-amp is an ideal one. Okay. So before we solve this problem, first I am making the equivalent diagram of this op-amp based circuitry, which clearly indicates the how it is a negative feedback. So for the time being, I am just showing you the this path is our feedback feedback network. Okay, and the above one we can say this part is our amplifier section. This part is our amplifier section. Okay, I'm just writing this one is our amplifier, and this green one you can say the feedback amplifier. Okay, so now if we draw the equivalent circuitry of an op-amp, so how we can draw the equivalent circuit for the op-amp? So this one plus minus, okay, this one is grounded, and this one is you can say as a VI, amplifier gain A, and this one is our say VI, and this one is our grounded. Okay, and one can also put this RS here. A very interesting question, and this should be our VS plus or minus. Okay, now there is a load connected, so we can directly put this RL here. Again, from this inverting terminal, that is our this one, R2 is connected to the output section of an amplifier, so we can make it R2, and one can make this as a R1. So again I am just highlighting the part. This one is our simple amplifier, and the another one is our feedback amplifier. Okay, amplifier and feedback amplifier. So now what we can say, this value, this one is our, we can say, plus or minus VF, feedback voltage. Okay, and this value will be our simply V0. Okay, so the very first question, find an expression for a feedback factor beta. So I'm just taking the part A. So in this case, we can, if we have to find the value of R2, and this one is our R1, okay, grounded one, and this one is V naught, and plus or minus this one is our VF. Okay, so the feedback factor beta, okay, this amplifier have a beta feedback amplifier again. So this beta is nothing but simply VF by V naught. This one is a output and this one is a input. VF is our output and V naught is a input. Okay, so we can say this beta is nothing but simply Vf by V naught. So now this value is V naught, so just we have to apply voltage division rule. So we can easily say this Vf is nothing but simply the this voltage input voltage, we can say in that time V naught into the opposite resistance R1 by R1 plus R2. So we can say Vf by V naught is simply our R1 by R1 plus R2, and this one is our beta. Okay, so this one is the first question, find the value of the beta. Okay, so just we have to apply voltage division rule. Okay, so if someone don't know the formula for that one, say this one is a R2, okay, and say this one is a R1, anything you can say, and if some voltage is there, say Vi. So if we have to write V naught, what we have to write? V naught is just Vi into take this resistance R1 by R1 plus R2. Okay, it is very simple. So this one is just an example. Okay, so first part is over. Beta value we have calculated. Okay, now next problem. Next part is our part B. If the open loop gain is 10 to the power 4, so given A is 10 to the power 4, we have to find R2 by R1, we have to find. Okay, and in this question, closed voltage gain AF is also given. AF is also given 10. Okay, so here AF value is much less than A, so this one is also a negative feedback. Theory part I have cleared in my videos. So this one is our negative feedback where amplifier gain is much greater than the AF. Okay, so now we have to know the formula for this one. AF we know A by 1 plus A beta for a negative feedback. It is very important formula, or you can derive, or we are doing numerical, so we are directly writing AF equals to A by 1 plus A beta. Okay, so from here we have to find the value of what? R2 by R1. Now beta is a function of R1 by R1 plus R2. So we will put this value, okay, and then we can also find the value of R1 by R2. So for this thing, what we have to do? AF is there, A by 1 plus A beta. Okay. So what I am doing, we can write this AF into 1 plus A beta equals to A. Okay. Or we can write 1 plus A beta equals to A by A. A by AF. A is our 10 to the power 4 by AF is 10. So we can write it 10 to the power 3. Okay. Now if we solve, A beta can be written as 10 to the power 3 minus 1. So 10 to the power 3 minus 1 is nearly 10 to the power 3. We can write. Okay. A beta is 10 to the power 3 minus 1 is 10 to the power 3. Now this beta is our 10 to the power 3 by A. Okay. So 10 to the power 3 by A. A is our 10 to the power 4. So it is our 10 to the power minus 1, or better to write 0.1. The approximate value. So beta value we have calculated 0.1 from this expression. Now beta is nothing but simply our R1 by R1 plus R2, 0.1. Okay. Now what we can write? We can write R1 plus R2 by R1 equals to 1 by 0.1. Just we are reversing. Okay. Or we can write it this as a 10. Okay. So now we can write as 1 plus R2 by R1 equals to 10. So I am writing in that side. So R2 by R1 equals to 10 minus 1 is nothing but simply our 9. So this one is the value of R2 by R1. It is very simple. 10 minus 1, 9. So because we have to find the first, we have to write this main equation. Okay. Then we are writing this one, 1 plus A beta equals to A by AF. Okay. So it is 10 to the power 3, 10 to the power 4 by 10. And A beta 10 to the power 3 minus 1. So it is nearly 10 to the power 3. Okay. Next beta value we have calculated from this one, 10 to the power 3 by 10 to the power 4, it should be 0.1. Then beta, and beta value with the R1 by R1 plus R2. So again we have written this one. Then we just reverse the term. Then we can easily write this 9 and R2 by R1 9. Okay. So this one is the value of R2 by R1. Okay, which is coming 0.1. Beta value is beta value how much? 0.1, and other one we can calculate it. Okay. Now we have to go for the third one. C part. What is the amount of feedback? So C, amount of feedback. Amount of feedback is nothing but simply 1 plus A beta is our amount of feedback. So what is the amount of feedback? So we can say 1 plus A is, amplifier again is very high, 10 to the power 4, and beta value we have calculated 0.1. Beta 0.1, 0.1. So this is somehow 10 to the power 3. Okay, nearly 10 to the power 3. And if we find the value of amount of feedback in dBA scale, we have to write 1 plus AB, and it should be 20 log 10 to the power 3, then it should be 60 dB. Okay, so this one is the value for the amount of feedback in dB. Okay, 10 to the power 3 we can say, or 60 dB. Is it okay? Now this one is a part C. Part is clear. Now we have to find the value of V naught, Vf, and Vi. So D. D part. So in D part, what is given? Vs is 1 volt. Okay. Vs is 1 volt. We have to find V naught, Vf, and Vi. We have to find all these parameter. Okay. So Vs is given. So we can easily say feedback amplifier gain AF is nothing but simply V naught and Vs. Okay or not? So we can write this AF equals to V naught by Vs. So V naught can be written as AF into Vs. Is it okay? Very simple. Output by input. V naught by Vs is nothing but simply AF. So now the value of AF is already given 10. Okay. AF is 10 into Vs is 1. So it should be the value of 10 volt. So output voltage will be 10 volt. So V naught 10 volt. I am highlighting this part also. V naught 10 volt. Okay. Now we have to find the value of Vf. Vf. So what is the value of Vf? So for Vf, what we have to do? Vf is nothing but simply beta times of V naught, because this one beta. Okay, feedback gain. This one is V naught and this one is our Vf. So beta equals to output is our Vf. Okay, and input should be V naught. So Vf equals to beta by beta into V naught. So beta value is known to us, that is our 0.1. 0.1 into V naught is 10. 10, so 10, so it should be 1. So Vf value is 1 volt. Again I am highlighting this. Vf is 1 volt. Okay, it is 1 volt. Okay, and one more thing is there. If we find more accurate value of what beta, then we can also find, suppose for the time being, I am writing one more expression for, because this beta is the approximated one. I am writing here approximated one, beta approximated value. Okay, now if beta, if someone want to derive the exact, be accurate, so again I am writing AF equals to A by 1 plus A beta. Okay, AF is our 10, 10 to the power 4, 1 plus A is our 10 into beta, so 10 to the power 4. So if we go for this expression, we can write 10 plus, I am just solving the exact value of beta, because it will help in the next problem. So it should be 10 to the 5 beta by 10 to the power 4 minus 10. Okay, 10 to the power 4 minus 10, so it should be 9990. So beta value will be 9990 by 10 to the power 5. Okay, 9990 by 10 to the power 5. If we divide this one, so 10 to the power 5 is there, 10 to the power 5. Okay, so if we divide 999 by it, now it should be 10 to the power 4, so it will be around 0.0999, which is nearly equals to 0.1. So this one is the exact one and approximated one. So this one is also we have to keep in our mind. That's how to find all these things. Okay, so now the last one, we sorry, this one, V naught is calculated, Vf is calculated. Now we have to find the value of Vi. Okay, na? Vi. We have to find the value of Vi. Okay, so in for the calculation of Vi, what we can say, if this one is a amplifier, this one is V naught and this one is our Vi. So A equals to V naught by Vi. So Vi equals to V naught by A. So V naught is 10 and it should be our 10 to the power 4. So 10 to the power minus 3 or we can write it 0.001 volt. So this one is the value of Vi 0.001 volt. Okay, again I am highlighting the Vi value. Okay, so we have calculated all other values of other term. This one is our R2 by R1. We have calculated V naught Vf. Okay, all other. Okay, now this D section is over. Now we have to go for E. E question is, if A decreases by 20%, what is the change in AF? Question number E. If A decreases by 20%, what should be change in A? So this one is very interesting question and very concept will be clear after making this problem, this particular question. Because other is just we can say the formula based, but we have to know the some basic concept. So in this case, what we are saying, if A is decreased by 20%, so for example, now I am writing initially the old A value is 10 to the power 4. Now we are saying A is decreased by 20%. So first we have to think now what should be the value of A new. Okay, so how to think? So we can say if initially 100 will be the amplifier gain. So after 20% reduction it should be 80. Suppose this one is our A old. So 20% reduction. So A new will be 80%. A old is suppose 100%. So it should be 20% reduction. So 80. So now we can say when it is A value is old value is 1. So it should be 80 by 100. So if I am saying it is 10 to the power 4. So the new value will be 80 by 100. This one is a unitary method to solve. Okay. So it should be 0 0 cancel. It should be our 0.8 into 10 to the power 4. So we can say the A new value will be 0.8 into 10 to the power 4. Okay, it is clear. Now we have to find the value of AF. Okay, we have to find the value of AF. Now we have to find the value of AF for this particular value. Okay, so AF new will be our A by 1 plus A beta. Okay, so this will be our A new. So it should be our 0.8 into 10 to the power 4 by 1 plus 0.8 into 10 to the power 4 into, we can take 0.1. Okay, or we can take the value of the original one 0.00999. Okay, 0.1 or beta value 0.0999. Okay, now we have to solve this one. So I am just solving this one. 1 plus 0.8 I am solving. So I am using the calculator 0. I am doing in my calculator 0.8 into 0.0999. So it will come around 0.07992 into 10 to the power 4. Okay. So 1, 2, 3, 4, 5. Okay. So one more line I want to write. Then one can write, if we remove this decimal, it should be 1, 2, 3, 4, 5. So if for this 4 it should be 4. So 1 plus 7, 9, 9. Uh, okay, this should be cancel out. So 799.2. Okay. Now again, what we can say now. Actually, we have to solve this one. That's why I am doing 10 to the power 4 by 1 plus 7 point, sorry, 1 plus 799.2, 800.2. Okay. So now if we divide 0.8 divided by 800.2, it will come 9.9975 into 10 to the power minus 4 into 10 to the power 4. So it should be cancelled out. So it should be 9.9975. Why I am doing? Because the A new, initially the A new is 10. Okay. So the AF old value was 10. Now the AF new value is just coming 9.9975. So very small change in this one. So that's why this property is our gain desensitize. Desensitize. So now how much percentage we have to find? Means how much percentage we have to find. Our this value is our AF new when A is decreased by 20%. This is very important. We have to do this very simple calculation, but we have to very patient and very cool and calm. Okay, so this AF new is this one. So now we have to think about the percentage. So how we have to think the percentage? So what I am writing AF old value, and I am writing AF new value. So when it is 10, okay, now the new value is 9.9975. Okay, when it is 10, it is now it changed to 9.9. When it is 1, so it is changed to 9.9975 by 10. Now we are saying it is 100. When we are saying it is 100, so what we can say, just unity method, 9975 by 10 into 100. Okay, 10 into 100. So this should be cancelled out. So it should be 99.975. So how much change is there? So how much change? So change will be 100 minus 99.975. So if we solve, I think 0.025, 100 minus 99.975, 0.025% change in F only. Okay, so if there is A is decreased, the A is decreased by 20%, 20%, the F change is also decreased by only 0.025%. So this property is our gain desensitize. Okay, so this one is the very fruitful property of the negative feedback. Even if there is a change in a large change in amplifier gain, the feedback can only change by very small or minute change by around, if 20%, it should be 0.02. So this one is very important and very fundamental question, which is based on the non-inverting open based negative feedback. So more detail you can follow the Sedda and Smith book. Okay, Sedda and Smith book is there for microelectronic circuit. Sedda and The Smith book. Okay, the book name is Microelectronic Circuit. Microelectronic Circuit. If you are looking for the fifth edition, I have fifth edition. So in this fifth edition, this one is exercise number is 7.1. Okay, so this is all about this question. So thank you for watching this video.